All right, and we are back. So we are going to now take these two different ways of writing the geometric sequence, and we're going to practice just writing them in the forms. And then after that, we will practice actually using the formulas to solve problems. Okay, so remember the recursive form. You're multiplying by a constant number. So to write it in this form, you're going to take your previous term and you're going to tell what you're multiplying by to go from the previous term to the next term in the sequence. So when it asks a question like this, it says, write the recursive form of the following geometric sequences. Then you're going to be looking at this. Okay, so for instance, with this one, if I'm writing it in recursive form, I'm going to have to find what is the pattern. What number are we multiplying by? So I'm going to kind of start thinking through it, and you can either remember reason through it, or you could simply use that little shortcut that we talked about where you take one of its terms over the previous term. Okay, so if I'm writing this in recursive form, well, what am I multiplying 3 by to get 6? What am I multiplying 6 by to get 12? So if you kind of think through it, if you multiply by 2, that will do it for you. All right. So if I'm writing the recursive form, it would be a sub n. You leave that the way it is. And then the a sub n minus 1 term, that's the term before that one. What am I doing to this to get to that next term? Well, I have to multiply it by 2. So that's the formula, and then remember, you always have to put a term that's in your sequence, so we usually put the first one. So my first term in my sequence would be, well, the first term is 3. And that is my recursive form. Now, another way that you may see this written, because normally if you're taking a variable times a number, they will typically put that number in front. So another way that this could be written, so I'll just put or, is you could see it like this, where they actually take this 2 and put it in front of the a sub n minus 1. It actually means the same thing. And then again, they have to put what the first term is, and so I'll go ahead and write that over too. All right, so those are two different ways that they could write the recursive form. Okay, so just to practice it one more time. If we're doing it with this one, I'm going to think through the same thing. What am I doing to go from one term to the next? Am I adding? Am I multiplying? What am I doing? And so the reason I say it like that is because you don't know what type of sequence it's going to be usually. So like, what if I thought that this might be an arithmetic sequence? Well, then I'm going to start thinking to myself, arithmetic, you're adding the same number. So like, what am I adding to 8 to get 2? Well, if you kind of think through that, you actually have to add a negative number, or in other words, subtract a number. So like to go from 8 to 2, I'd have to technically subtract 6. So to be arithmetic, I'd be subtracting 6 each time. And notice if I take 2 minus 6, that doesn't give me that. So that means it's not arithmetic. So then to be geometric, I'd be multiplying by a constant number. And so I'd have to think to myself, what do I multiply 8 by to get 2? And that may be a little harder for some people. And so if it is hard, remember, you can go down or kind of to the side and figure that out. So I take one of its terms, so I could take 2, and I put it over the term right before it. So the term right before that is 8. And when I simplify, that reduces to 1/4. So if it's geometric, then that means I'm technically multiplying by 1/4 to go from one term to the next. And so if I check it, 8 times 1/4 gives me 2. 2 times 1/4, it would give me 1/2. And then if I do it again, if I multiply this by 1/4, I will get 1/8. So that means it's geometric. And so then to write the recursive formula, you take a sub n equals a sub n minus 1. Notice that part is always the same for these. And then you have to think, okay, what am I doing from one term to the next? Well, in these problems, I'm multiplying by a number. So you just have to tell what number am I multiplying by. And that would be 1/4. And then don't forget, you always have to put your first term. So my first term in this problem, or you have to put a term, in your sequence. So the first term in that problem is 8. Okay, and then don't forget the other way that you could write it, so we'll go ahead and write this one the other way too, is you could put it as a sub n equals, and then it'd be 1/4 times the a sub n minus 1. And then my first term was 8. Okay, so that's the recursive form of the geometric sequence. All right, so now let's practice the explicit form. So I'm going to flip it over. The explicit form, and I'll just copy it over for a geometric sequence, is different than the arithmetic sequence formula. So remember, to write the recursive form, you have your first term times your common ratio, and then it's to the n minus 1 power. Okay, so if we're writing a geometric sequence in this form, we're just got to find our first term and our common ratio and plug it in, because everything else will stay the way it is unless we're actually solving a problem, which I'll show you that in a little bit. Okay, so if I'm writing this sequence in recursive form, I have to find my first term. So my first term would be 3, so a sub 1 equals 3. And then I also have to find my common ratio. So what is the pattern here? What number am I multiplying by if it is geometric? And so what am I taking 3 by? Well, 3 times 2 gives me 6. Okay, notice this was a sequence that we just talked about. So my common ratio ends up being 2. Okay, and so now all I'll have to do is plug it in my formula, and that will be the explicit form. So my first term was 3, so it'd be 3 times my common ratio, and usually we put the common ratio in parentheses. It would be 2. And then it's to the n minus 1 power. You actually cannot simplify this any more than that, because remember what I told you before is the 2 is technically to this power. So because we can't actually do anything with the exponent right now because it's got an n in it, we cannot take the 2 to that power so that we can then multiply by 3. The mistake that most people make is they try to take 3 times 2. You cannot do that. Think of the order of operations. You have to do the exponents first. And so because of that, this is actually as far as we can go with the explicit form. Okay, so then this one, my first term is 8, and then my common ratio, we did this a second ago, you have to take one of its terms, so like for instance 2 over the one right before it, which is 8. Okay, so 2 over 8 reduces to 1/4. So that's my common ratio. So if I am writing this in explicit form, then I'd take my first term, 8, times my common ratio. So my common ratio is 1/4, and then it's to the n minus 1 power. So why is it useful to be able to write this equation? Well, once you get the equation for a sequence written down, I could ask you any kind of question I wanted to, and you would probably be able to answer it in terms like, what if I ask you, I give you this sequence, and I ask you to find the 100th term? Well, remember, n is the position of the term. So if I'm asking you for the 100th term, then what you're going to do is take 100 and plug it in here, and you just simplify it, and it will give you what the 100th term of that sequence would be, which would be a pretty drastic number. You'll find out in a minute. Okay, so now how do we actually solve problems with these formulas? Okay, so like if you look at, for instance, number 5, it says find the 6th term in the sequence. Okay, again, if it's a term that's not very far down in your sequence, you need to just think recursively. What am I doing from one term to the next? So in other words, just find the pattern and just keep it going. So for instance, what am I doing to 1 to get 5? What am I doing to 5 to get 25? So on and so forth. Once you find that pattern, you can just very easily keep it going to find the 6th term. So if it was arithmetic, I would think, what am I adding? So like if it is arithmetic, I'd say, okay, what am I adding to 1 to get 5? Well, I'd have to add 4. So if I add 4 again, would I get 25? And no, I wouldn't. So let's see if it's geometric. Am I multiplying by some number? Well, what do I multiply 1 by to get 5? And so I'd have to multiply by 5. Okay, so then if I take 5 times 5 again, would I get 25? And then if I take 25 times 5, would I get 125? And the answer is yes, I would. So that means it's geometric. And so I just keep that pattern going until I get to whichever term they're asking me for. So if I take 125 and I multiply it by 5, I would get 625. And then if I took 625 and I multiplied it by 5 again, that would give me 3,125. And so notice, if I count, that's the first term, second, third, fourth, fifth, sixth. So this would technically be my answer. So I would say, using our notation, the term that's in the 6th spot would be 3,125. Okay, so that's thinking recursively. Okay, so now if they ask you a question like this one, find the 30th term in the sequence. Okay, well, the 30th term would be one where it would take me a while to get that far. And so instead of me just thinking recursively, what am I doing from one term to the next, I'm going to have to use my explicit formula. Okay, so I'm going to copy down my explicit formula. Excuse me. My lead, gotta love my lead. So when I copy that down, there we go. And then I have to plug in what I know and what I'm looking for. So I know that I'm finding the 30th term. So technically, I'm finding the term in the 30th spot. So that would be a sub 30. And then I have to know my first term. Well, my first term is 1. So that'd be 1 times. And now I have to find what my common ratio is, okay? Well, what am I multiplying by, okay? And again, if it's not that easy, you could always go to the side and take one of its terms over the one before it. But if I kind of think through it, what do I multiply 1 by to get negative 1/3? Well, I'd have to actually multiply by negative 1/3, okay? And notice how the signs alternate here. Like the 1 is positive, this is negative, that's positive, that's negative. Whenever it alternates like that, that tells you that you are actually multiplying by a negative number, okay? And so try to remember that because that'll actually help you here, okay? So if we do this, my common ratio, which remember I said I usually put in parentheses, so I'm going to change that to parentheses. My common ratio would be negative 1/3. And then we have to the n minus 1 power. Remember, n is the position of whatever this term is that you're dealing with here. So the position that I'm looking for, or of the term I'm dealing with, is 30. So that'd be 30 minus 1, okay? And now I have to simplify. So remember, I said you cannot technically take this number times this number until you deal with the exponent. And so that's what I'm going to concentrate on first, is how do I take this negative 1/3 to the 30 minus 1 power, okay? Well, first of all, I'm going to simplify my exponent. So when I do that, it would be 1 times negative 1/3 to the, well, 30 minus 1 is 29, okay? So an exponent rule that you may or may not remember with doing this is when you have a fraction to an exponent, you could actually take each part of that fraction to that exponent. So I'm just going to take this negative and I'm going to put it with the 1, okay? And again, I'm going to carry that 1 in front over because I can't actually multiply it until I deal with everything else or deal with the exponent. So I'm going to take the negative 1 to the 29th power, and then I'm going to take 3 to the 29th power. Okay, the reason I had to put that negative 1 in parentheses is because I have to bring that all to that power. Okay, so how do I do that? Well, all right, again, I'm going to bring that 1 over. Negative 1 to the 29th power. Well, it's negative 1 times itself 29 times. So if I do that, I end up getting, negative 1. And then on the bottom, 3 to the 29th. I just want to show you something calculator-wise. All right? So, whoop, low battery. Gotta love the low battery. When I type in 3 to the 29th power in my calculator, I get the 6.8630 E13. Remember, that is a form of scientific notation. What that actually means is you are taking 6.86, all that mess, okay, I'm just going to round it to the nearest hundredth, times 10 to the whatever power is the same as the number that is behind the e. So this is technically 10 to the 13th power. Okay, so with that, if you actually had to write that number out, because this number is a positive number behind the e, that actually means that this is a really big number. And so this is how many times, this 13 is how many times you're going to move that decimal to the right. So I'd have to actually move that decimal 13 times to the right to actually be able to write that number out. Okay, so instead, I'm actually going to leave it the way it is for now, so you get used to seeing it in scientific notation. And so after we do this part, now we can take this times the 1. Well, 1 times anything ends up being whatever this number is. And so for this answer, we would have, for the 30th term in that sequence, it would be -1 over 6.86 times 10 to the 13th power. Okay, so this little problem covers a lot of stuff that you will have to know for certain types of problems, things that could come up. So that's a good problem. Okay, so then the last problem, it says what is the first term of a geometric sequence where the 10th term is that, and then the common ratio is 4. So because it's asking you for something other than like the next term or whatever, I would think explicitly about it. So we're going to copy down the explicit formula again, and we're going to see, this is one of those problems where you're going to have to be clever. We're going to see how we can use this equation to help us find that answer. Okay, so remember yesterday I told you, if they're asking you to find a term somewhere in your sequence or something else, like the common ratio, you can actually be clever. So whichever term that they give you, use that as your a sub n term. Okay, so like this term they tell us is our 10th term. So that's actually what I'm going to use here. So my negative, what is that, 262,144. I'm going to use that as my general term in my sequence. And we're going to have to remember what the position of that term is. So remember that's the 10th position in just a second. And then I have to actually find my first term. So I'm going to leave that the way it is. And then that's being multiplied times, the common ratio was 4. And then that's to the n minus 1 power. This is where you have to remember that. Remember the position, the n right here is actually the position of this term. So the position of this term, it was the 10th term. So this would technically be to the 10 minus 1 power. Okay, so from here, all we have to do is simplify and then solve for my first term. So I'm going to take the 4 to the, well, 10 minus 1 is 9. So I'm going to take 4 to the 9th power. And when I do that, 4 to the 9th ends up being 262,144. So that's what that becomes. And then I'm just going to bring down this side of it. Okay, and then from there I have to solve for my first term. Well, this is being multiplied times that, so to get rid of this number, to get the a sub 1 by itself, I have to divide by that number. Okay, so when I divide, those go away, and then my first term ends up being, when I divide these two out, I get -1. So if I actually worked backwards from the 10th term, because remember that's the 10th term, all the way back to the first term, it would end up being just -1. So hope this helps. Let me know if you have questions. You can email, or you can just simply tell me in Zoom whenever we meet. But have a good day.